In this lesson, we'll look at how to solve word problems that use scientific notation, but we will also draw from our understanding of the 3 exponent rules that we learned earlier in this chapter. As you get started with this lesson, let me encourage you that if you do not have a calculator handy other than your iPad, go ahead and pause the video now and get yourself a handheld calculator. Here we have just some generic rules about how to solve problems written in scientific notation. Notice that we have a set of rules that would apply to adding and subtracting, and then we would have another set of rules that apply to multiplication and division. And I want you just to know that these are here as you're working practice problems. I would encourage you to have this page up and in front of you just as a good reference point. Let me just point out specifically on the adding and subtracting side, it is important that you check the exponents. They must be the same before you can add or subtract. They must be the same. If that's the case, then go ahead and add or subtract your whole or decimal numbers, and then make sure you include your times 10 with the exponent at the end of the answer. On the multiplication and division side, let me point out that it is important that you will have to decide whether to add or subtract the exponents, and that's based upon how the problem is written. If it's a multiplication problem, we'll be adding our exponents. If it's a division problem, we'll be subtracting our exponents. So just a couple important things to keep in mind as we move forward. So let's look together at example number 1. It says 9.45 times 10 to the 5th plus 3.6 times 10 to the 5th. So if we're going to add numbers in scientific notation, our exponents must be the same. So we have a times 10 to the 5th and a times 10 to the 5th. So that means we can go ahead and we can complete this addition problem. We're going to go ahead in our answer and write times 10 to the 5th power, because we'll maintain the same exponent. And then what we're going to do is we're going to take our 2 decimal numbers and we're going to add them together. So we're going to grab our calculator and add 9.45 plus 3.6, and we get an answer of 13.05. So right now our answer is 13.05 times 10 to the 5th power. Now let's consider that answer. Is that written in scientific notation? No, 13 is too large, so we're going to have to go one more step. We're going to have to change 13.05 to 1.305. Right, so we go to 1.305. And we move the exponent back one place. So we're going to add an exponent to the exponent that already exists. We now have 1.305 times 10 to the 6th power. Again, why did we add an exponent? Because 13.05 is greater than 10. So we move the exponent back, the decimal point, back one more time. So we increase the exponent by 1. Let's look at number 2. Number 2, we have a subtraction problem. So let's check our bases. It's both times 10 to the negative 4th and times 10 to the negative 4th. So let's go ahead and write that as part of our answer, times 10 to the negative 4th. And then we're going to subtract our 2 decimals, 7.2 minus 1.3, and we get 5.9. Now let's check our answer. Is that written in scientific notation? Yes, we have a number that's greater than or equal to 1, but less than 10, with our times 10 and an exponent. So that one is already written in scientific notation. We don't have to do any additional work. Number 3, 1.25 times 10 to the 6th times 7.6 times 10 to the negative 8th. So remember, we have a different set of rules with a multiplication problem. The rules with multiplication say we multiply our 2 decimal numbers. So we multiply 7.6 times 1.25, and we get 9.5. Now, our rule says that when we're multiplying, if we have the same base, which we do, we have times 10 and times 10, we add our exponents. So 6 plus negative 8 is negative 2. We have times 10 to the negative second. Let's check our answer and see if it's written correctly in scientific notation. And it is. We have a number that's greater than or equal to 1, but less than 10. And we have our times 10 with an exponent. Example 4. We have a division problem. So when we have a division problem, we divide our two decimal or whole numbers. So 4.56 divided by 1.9 equals 2.4. Now we have a times 10 to the 9th and a times 10 to the 2nd. If we have a division problem and the bases are the same, we subtract, so 9 minus 2 is 7. We get a final answer of 2.4 times 10 to the 7th power. Number 5. Again, we have a division problem. So let's divide our exponents. Exponents. Let's divide our decimal numbers. 1.44 divided by 1.6 gives us 0.9. We have times 10 to the negative 15th and times 10 to the 2nd. So we have the same base. In a division problem, let's subtract our exponents. Negative 15 minus 2 is negative 17. So we're going to have 0.9 times 10 to the negative 17th. Now, check that answer. Is that written in scientific notation? No, 0.9 is not greater than or equal to 1. So we're going to have to move our decimal point. Now think about that. This number is less than 1. We're moving the decimal point forward one place. When we move the decimal point forward, we use negative exponents. So we're adding an exponent of negative 1 to the existing exponent of negative 16. So we're going to have 9 times 10 to the negative 18th. Let's look at example 6. We have a multiplication problem. So we're going to multiply our two decimal numbers, 6.2 times 5.5. We get 34.1. We're going to add our exponents on the times 10 to the negative 7th and times 10 to the negative 12th and get times 10 to the negative 19th. Now, 34.1 is too large, so we're going to move our decimal point backwards a spot, right? We're going from a number that's too large to a number that's small enough to be in scientific notation. We use positive exponents in this case, so we're going to add 1 to our existing exponent to give us an answer of 3.41 times 10 to the negative 18th. Number 7, we have an addition problem. Okay, remember the rules for addition are different. We add the two decimal numbers, 9.03 plus 9.03 plus 4.5 equals 13.53, and then we keep the same base and exponent, so we keep the times 10 to the 5th. Now when we check that answer, it's not written in scientific notation, so we move our decimal point back a place to make it 1.353. We moved the decimal point backwards. We went from a number that was too large into scientific notation. So we use positive exponents. That means we add 1 to the existing exponent. And we have times 10 to the 6th power. If you would like more help on this concept of which way do we move the decimal point, and do we add an exponent or do we subtract an exponent, let me encourage you to plan in your next class period to sit in a teacher-facilitated section so that we can go over this together a little bit more before you take the checkpoint.